20 years ago was the bad time, but right now, no matter your age, no matter where you are at, right, this is the right time to break into tech. You go through it, you see all sorts of open source models, image to 3D, right? Text to 3D, right? Image feature extraction, etc. But let's go back to what we are doing. Okay, so we're going to try this. So you see, this is a research demo, may not be used for any commercial purposes. So you see, this is why you have to read these fine prints, right? This research model is not open to residents. Okay, forget about that. This is Meta. Meta, yeah. So what I'm doing here is animated drawings. But you can do anything you want to do. You can try anything you want to do. Yes, it's free. Yes, it's free. Just to learn, you know. So here you upload a drawing, so you can draw on paper, right? Maybe you are I mean, it's not that good, but it's a great start. But Hugging Face has better models, right? Like this. So let's experiment. So let's upload a video, upload an image. Okay, so this is an image, right? Okay, so it has scanned the image. Okay, so now it doesn't look so good. It doesn't look so good, but you are getting like the concept, right? Yes. You know, it's still something. And you see, the thing is that these models, they can be fine-tuned. So the more you do them, it gets better. The more you do them, it gets better. You understand? The more you do them, it gets better. You know, but it just gives you, what you're doing is, when you're checking out these tools, you're priming yourself, you're empowering yourself, you're stretching your horizon. Do you understand? So that you can be better informed, you can understand, you know. So I'm just going to, what I'm going to do is I'm going to play the video I played first, just for some of us who just joined, so that video is just 2 minutes. Sorry for some of us who need to watch it again. So you can just understand the base of some of what I'm talking about. So let me just play that video and then we'll move on from there.
As related to the digital environment, to measure, to know where the 5G devices will be installed and to be effective as vehicles go along the path. So that's what I was able to get from that. I'm not sure how great that was.
Yes, that's very good. Yes.
The signal strength of the 5G network.
Yes.
Simulating real life events and observing it, so that way infrastructure and everything, to make sure to see what the problem is at any time, see if maybe there is a weakness in the bridge. You don't have to walk up to the bridge and check each part of the bridge. You have everything simulated on an identical environment that you can use. I'm not sure if you've heard of the metaverse, but this is definitely a twin to the metaverse. Yeah.
Awesome. Thank you very much. Okay.
A few questions I have is, how do you really test for the strength? For example, the material that you use in designing the bridge, how do you really test for the strength of each part of the bridge? Maybe if there are variable loads going over the bridge, how do you know that this part of the bridge is strong, this part of the bridge is weak? If there's specific measurements or anything or transistors that need to be put there so we can test if actually this part is strong, because it's easy for us to just say we can simulate and put it on a different environment, but this is a real structure where humans actually pass. So how can we really tell that what is given to us in the virtual world is actually what's transmittable in the real world?
Yeah.
So people humans actually pass the bridge.
Yes. So that's a very, very good question, right? Right. That's why I love data science, because what you're describing is actually just having data points, data entries. So for example, if Sanlu, or maybe not Sanlu, maybe commissioner for, what do you call it? Commissioner for what? Road, works. If the commissioner for works gives that project to you as a product manager, you're going to gather a team of data engineers, right? And then the existing team, maybe the person that even designed the bridge and built the bridge, or the people who maintain it, and then you're going to have a structure for them to impute all those data points. Some people are already doing it, some construction companies are already doing it, so you might be able to use their services, maybe use their pre-trained model, but if you are doing it from scratch, that's all you need to do. So you get the data points, you put a CCTV camera that has object detection, right? I was talking about that yesterday, that tracks everyone moving, so if it's a van, it registers as a van, it's already been trained. It's an image and a video model that has been trained. If it's a person, it records as a person. So in a day, you know how many cars pass, what type of cars are passing, how many trailers are passing. If it's male, if it's female, to that detail. If it's a small person, you can even calculate the total weight that goes on the bridge daily, right? So everything falls down to data. And that's why I love mathematics, right? Because it falls back a little bit to mathematics, calculus, probability, statistics, and etc. But thank God for what the amazing scientists are doing. They've done the heavy work for us. And so if you are an engineer, or you have an engineering or a construction company, and you are tasked with that, and you can put your sensors too, you just look for data ends, things you would put to collect data. Then you'll also leverage the existing data that the engineers, because I'm sure that anything that is built for the government is stored somewhere, in either paper form, or in the cloud. And once you do that, then you now create a digital twin of it, and you keep feeding the data, because you keep checking. So it doesn't mean that when you have a digital twin, there's not going to be any, physical, checks or whatsoever. Okay, you want to ask me?
Yeah, just to quickly add to it, I think what you said is very simple, and that's one of the things I think we should also stand, because it goes back to first principles thinking. Like what he said, the aim of, or part of the aim of technology sometimes is to improve what you're already doing, to make it better, to make it quicker, to make it bigger, to make it faster, to make it clearer, in different ways. So first principles thinking, these guys already know that they should do these things. They're quality engineers, they're different things. The only difference is they don't have enough information to time to know that are we supposed to do this repair in 6 months or in 3 weeks. So whatever he has said and whatever AI is helping to do is to help that quality assurance QC person, and that's to do what they should have done in 3 months, because they will say let us fly down this. They will not do it in probably 3 weeks. Because as an engineer who has been trained and first puts you don't have to be an engineer to know that somebody needs to maintain this bridge. So that thinking already, you know how you want to do that thing better. What you always think from first principles. Why? Break it down like a 6-year-old will think. Because sometimes too much knowledge, too much education can help us, think things that are too complex. They are not really complex. It's just how we think about that problem, critical thinking. To say, if I want to approach it this way, then let me approach it this way. And that's it. That way we get things working faster, better, quicker, and
Awesome.
at the same